Chapter 9, Conic Sections. We're going to look at the four conic sections that are created from a double-napped cone where a plane intersects the cone. So on the first one here, you can see that the cone is crossed through by a plane, and this would represent a circle. So you can kind of see that right there. And then on the second one, if you go more at an angle, you create an ellipse. And then as you continue, so you can see that one's a little more oval, and then this one would represent a parabola. And then the last one here, it hits actually both sides of the cone, and it represents a hyperbola. And so those would be the four conic sections that we look at in this chapter. The one we're going to start with today is circles. Now, circles is not part of the chapter. It's actually in section B.1 in the appendix. So if you're looking for some information on it, that's where you need to go. First off, a locus is a collection of points that satisfies a certain geometric property. And so that's how we're going to look at all of the conic sections, is by a collection of points that satisfy the property. So a circle is a collection of all points x, y that are equidistant from a fixed point HK. Now you can see that the fixed point HK represents the center of the circle. And so I'm going to show you where the equation of a circle comes from. One of the things that we have learned is in geometry is the distance formula. Don't use it a lot in this class, but this is one instance where we can show and prove that a circle, where its equation actually comes from. So the distance formula, if you remember, is the square root of the difference of your x's squared plus the difference of your y squared. And that's really just Pythagorean theorem when you break it down. So we're going to find the equation of a circle with a center HK and a radius of r. So we're going to use these 2 points HK and XY to find the distance between them. So r, which is the distance between the 2 points, is equal to the square root, the difference of your x's, x minus h squared, plus the difference of your y's, y minus k squared. And then if we square both sides, you will get r squared is equal to x minus h squared plus y minus k squared. And that represents the equation of a circle in standard form, given the center is HK and r represents the radius of that circle. And so you can see once again the standard equation of a circle. I just rewrote it for you. X minus h squared plus y minus k squared is equal to r squared. So there's really two things that we're looking at: the center and the distance from the center to any point in the circle called the radius. So example 1, I want you to write an equation given the center at 4, -1 and a radius of 5. So just practicing writing the equation. So with the center, this represents the HK, which is your x and y value for the center, and then the radius is 5. So we have x minus h, so that's x minus 4 squared, plus y minus -1, so that's y plus 1 squared, is equal to r squared, so that's equal to 5 squared. So to simplify that, that's x minus 4 squared plus y plus 1 squared is equal to 25. So that's the equation in standard form. Now let's move to the next thing. We're going to identify the center and radius, and then we're going to go ahead and graph it. So the center, this one is in standard form already, so the center is 3, -2. Once again, remember this is y minus, so to get a positive 2, it's y minus a -2. And your radius squared is 16, so therefore your radius is 4. And so we'll graph the point 3, -2, and then we'll count 4 units in each direction, and then try to graph the best circle that we can. And there you go. Once again, center at 3, -2 with a radius of 4. On each of the conics that we learn, we're going to be able to write the equation in standard form. So I'm going to show you how to do this with a circle, but it's going to be very similar to the rest of the conics. we want to get that form that we had earlier, x minus h squared plus y minus k squared is equal to r squared. So to be able to get a binomial squared, we need to complete the square. So we'll go back over kind of how to do this. So the way I set mine up is I have my x squared plus my 4x. I try to get everything in line here, and I put a plus blank because that's what I need to add to create a perfect square trinomial. Plus, then I have my y squared plus my 10y plus blank once again. And then I'm going to go ahead and subtract the 20 over to the other side. But what I add to one side, I have to add to the other. So I'm going to add 2 more blanks to that side. So when I add to the left, I'll add to the right. So to complete the square, you take half your middle term and square it. So half your middle term is 2, 2 squared is 4. That's what gets added as your constant. All right? And so what then happens is that now x squared plus 4x plus 4 is a perfect square trinomial. And so that means that you can factor it into a binomial times itself, or a binomial squared. So that would be x plus 2 squared. Same thing on the next one. Half of 10 squared is 5 squared. So 5 squared is 25. And then that factors into y plus 5 squared. And this number here should always represent, this one and this one, always represents what half of the b value is. So in terms of these are pretty easy to factor, but when you get to fractions, it gets a little bit more complex. Now remember, we added 4, so we have to add 4. We added 25, so we have to add 25 to the right side, and then that will give us a value of 9. And there's your equation of a circle in standard form. The center is at -2, -5, and the radius squared is 9, so therefore the radius is 3. And that's how you write an equation of a circle in standard form. Alright, here's another example. If you look at this one, we got 4x squared plus 4y squared. So we can't complete the square with numbers in front, and since these with a circle have to be the same coefficient, we can just go ahead and divide everything through by 4. That'll give us x squared, and I'm going to write these in the right order as I go along too. So now I'm going to do the -2 divided by 4, so that's -1/2 x plus blank. Once again, we're going to work on creating that perfect square trinomial, plus y squared, and then 6 divided by 4 is 3/2, so plus 3/2 y plus blank, and then 5 divided by 4 is -5/4, so I'm going to add that to the other side, so that'll be +5/4 plus blank plus blank. And so once again, we're going to complete the square. So we need to take half your middle term, so -1/2 times -1/4, or sorry, -1/2 times 1/2 is -1/4, and then when you square that, you get 1/16. So that's what we're going to add to the left and to the right side. And so now that factors into x minus whatever half your middle term was, so that's x minus 1/4, and then plus y squared. So we have to take half of 3/2, which is 3/4, and then square that to get 9/16. So we'll add 9/16 to complete the square, and to the other side as well. So that'll be plus y plus, what was half of 3/2? 3/4 squared, and then is equal to those three numbers added together. We need a common denominator for 5/4, so we'll do plus, we're going to change this to times it by 4, so that'll be 20/16, and so 1/16 plus 9/16 plus 20/16 is 30/16. And so my center is at 1/4, comma, -3/4, and my radius squared is 30 divided by 16, but when I take the square root, I get the square root of 30 over 4. And so that represents the distance from the center to any point on the circle. So here's just another example of writing an equation in standard form. Yes, you do have to deal with fractions, but these are all things that we should be able to handle. All right, the last examples of all the conics that we're going to do is I'm going to have you guys work backwards. I'm going to give you some information, and you have to write the equation. So why don't you pause the video right now and see if you can work through these two examples where, once again, I give you information, and then you have to work backwards and be able to write the equation. Now in the first one, example 5, write an equation of a circle with a center of 5, -3, and tangent to the x-axis. Sometimes it's nice just to get a visual. So 1, 2, 3, 4, 5, -3. So here's the point 5, -3. That's the center. And it's tangent to the x-axis. So tangent, if something is tangent, it's going to cross through just a single point on the circle there. So if it's tangent to the x-axis, which is right here, then the circle is going to hit at that point because it would be tangent to the x-axis. So it would go through right there. And so your circle is going to look something like that. So we know this distance right here because we went over 5, we went down 3. We know that distance to be 3. So we know the radius is 3. We know the center is at 5, -3. So therefore we can write the equation x minus 5 squared plus y minus -3, but that's y plus 3 squared is equal to the radius squared. So make sure you put 3 squared, which is equal to 9. So here's your equation of the circle in standard form. On example 6, write an equation of a circle with endpoints of a diameter, -4, 2, and 6, -8. So they're telling you that these are the points of the endpoints of the diameter. So -4, 2, once again just kind of getting a visual here, and 6, -8, somewhere down here. So this is 6, -8, and -4, 2. Well, we don't have the center and we don't have the radius, but we can find the center because it's the midpoint of the 2 points. So the midpoint is the average of the 2. That's kind of the way I think about it. So I'm going to add my x's and divide by 2, and then I'm going to add my y's and divide by 2, and that will give me the midpoint of the 2 points. So that'd be 2 divided by 2 is 1, -8 divided by, or -6 divided by 2 is -3. So that gives me the center at 1, -3. So somewhere right here would be the center. That looks accurate. And then now we want to find the distance from the center to one of those endpoints. So pick one of them and the center and find the distance. So the radius is equal to, I'm going to take the point 1, -3, which is the center, and then I'll do 6, -8 as my other one. So the radius is equal to the square root of the change of x, 6 minus 1 squared, plus -8 minus -3 squared. So the radius is equal to, 6 minus 1 is 5 squared. -8 plus 3 is -5. -5 squared is 25. So 25 plus 25, that's the square root of 50. I don't need to simplify that because I want to know what r squared is. So if I just go ahead and square both sides at this point, that'll get rid of the radical, and we know that r squared is equal to 50, which is exactly what we need when we write our equation. So our equation would be x minus 1 squared plus y minus -3, which would be y plus 3 squared, is equal to the radius squared, which is 50. And so there's your equation in standard form, given 2 endpoints of the diameter, being able to find the center, and the radius using the distance formula. And so that is it for circles. Once again, with conics, we're going to be looking at all 4 conics: circles, ellipses, hyperbolas, and parabolas. And all 4 conics, we're going to be looking at, can we graph, can we write the equation in standard form, and can we work backwards. So once again, on this last slide, create a summary of what you just watched. What are those important pieces that we need to know?